The aviation forecasting of stratiform cloud amount. There's not always a straightforward method from an aerological diagram from a balloon flight to be able to forecast the amount of cloud that you'll observe, but we can supply some general principles. Firstly, altocumulus altostratus, or ACAS. You can determine the cloud amount obviously from a satellite image, but you can also make some estimation from the trace. If the trace is dominated by train tracks, that is a small dew point depression through a large depth of atmosphere, then it's very likely that the altocumulus altostratus will be broken. If there are dry slots in the trace, that is, there are large departures between the dew point temperature and the temperature, then it might be that you have multiple layers, and they don't always have to coincide. So that might be more likely that you have scattered ACAS. But again, you want to match what you see from the local trace with the broader scale, that is with the satellite image. It's always useful to mention the trend of the cloud, the ACAS amount, on an area forecast, and let pilots know where cloud is going to be and whether or not it's increasing or decreasing in amount. Stratus. Low-level stratus, we want to consider how moist the surface flow is and the trajectories near the surface. So, are we advecting moist air or dry air over the location? It's also worth considering rainfall and its impacts via the wet bulb process. So, you'll get broken stratus if you have moist near-surface conditions. That makes the wet bulb process more efficient. If you have a large dew point depression near the surface, then you might simply get scattered or even fused stratus. And it's going to depend upon that dew point depression in the boundary layer, but also how heavy the precipitation is going to be. In terms of precipitation, ACAS causes rain, which is heavier for deeper cloud, for reasons that will be explored in a cloud microphysics course, but also beware of dry air below the cloud base, which will result in virga, that is, precipitation that doesn't reach the surface. There's also drizzle, and drizzle occurs for thick stratus, so thick cloud near the surface of the Earth. In terms of general principles, in aviation forecasting, you're always concerned with what's happening now, both here and upstream, and the likely changes over the next 12 hours or so. A large number of aviation forecasts are only 12 hours long. So a first principle is trending from present conditions into the future.